Hello, I'm Morgan McCoy, and this is my MSE 512 webinar about the recycling of laser powder bed fusion powder. First, we'll start off with what laser powder bed fusion is, which is an additive manufacturing technique that uses a laser to melt metallic powders in a layer. You can see the process there on the bottom. It's often used in high-value parts due to its ability to produce complex geometries with high product quality. On the top left is a sample that I worked with that has a very large void in the middle of it, which would be impossible to produce with other techniques. Over 90% of the powder remains unused after production, but this can be used in more prints, but it does degrade during it. I'll now be going over how the powder degrades, and first off, we have a morphology change. Virgin laser powder bed fusion powder is nearly spherical, but spatter from the melted powder binds to the particles, adding satellite particles and deforming the shape. We have a visualization there on the right where we have a picture of the Virgin after one print, after 6 prints, and after 10 prints. And you can see that there's more and more satellites on the powder. You will notice that there is some on the Virgin powder, and to really show the difference, I have at the bottom the proportion of particle morphologies in between a virgin and recycled powder for Inconel 718. Next, we have an increase in trace element content. Some powders gather atmospheric elements during recycling. Oxygen is the most commonly studied element as many things oxidize, but carbon, nitrogen, and hydrogen have been shown to increase in content during recycling. On the left there, you'll see the increase in oxygen and nitrogen content of recycled powder, and on the left, you'll see it in steel powder. It's not well stated, but you can somewhat see an increase in carbon. Finally, there is a change in the powder size distribution. The spatter binding to other particles increases the size and generally increases the average particle size, but it also introduces smaller particles. On the top left, you'll see PSDs for Ti 64, Virgin 3X and 9X recycled powder. On the left is just the recycled powder. On the right is the sieved out powder, so that's going to be mostly two large particles. And on the bottom is a total PSD for virgin, 3 times used, and 10 times used recycled powder. With the effects to the powder explained, we'll start looking at how that affects the laser powder bed fusion process. First off, we have flowability, which is impacted by the decrease in sphericity and the increase in average size. The increased particle size increases flowability, while decreasing sphericity decreases flowability. The cumulative effect depends on the powder and material. On the top right, we have a chart for Inconel 718, which just depending on the test, there's both an increase and a decrease for each test based on number of reuses. And at the bottom, we have a alloy of steel, and you can see an increase in flow time. Next off, we have laser melting, which is a highly complex and essential factor in laser powder bed fusion. The change in shape and size affects heat transfer between particles and the flow of the melt, affecting the quality of the print. Decreased heat transfer can lead to a lack of fusion pores in the final part. On the right, we have two views of the laser melting process. Here at the bottom, we have a head-on view where you can see how initially there's a divot and then it bulges up. And at the top, you can see how that a side-on view of that same process with 0, 60%, 80%, and 100% recycled material. There is some changes between those cases. As a result of the changes in laser melting, we have a change in the microstructure. They have a direct impact on the porosity and on the melt pool. On the top right, you can see that porosity is inherent in the laser powder bed fusion process, but with more recycling powder, you do see an increase in porosity. There are also slight differences as a result of trace element inclusions, which can be seen mostly in the post heat treatment microstructure. The final thing I'll cover today, and probably the most important question, is how it impacts the physical properties of the part. Recycling has been shown to affect material properties such as yield strength and ductility, but an increase or decrease depends on the material and the build conditions, as there's a lot of variability in that. At the top right, you'll see a fatigue test of Inconel 718, where the reused powder has a shorter fatigue life. And at the bottom, we have ultimate tensile stress and strain at the ultimate tensile stress for some stainless steel. And you can see a definite decrease at the strain at ultimate tensile stress, which Goes to show that the reused powder is more brittle. To round things off, I'll be talking about recycling methods, and as a result, the vast number of materials produced with laser powder bed fusion. There's not an established method for powder recycling. Common methods include reusing powders for a set number of cycles, mixing recycled powder with virgin powder at various mixing ratios, and processing recycled powders with sieving. Future methods could include the use of plasma spheroidizers to reprocess the recycled powder to more uniform shapes. Oftentimes, they'll use a mix of the common methods, as you can see on the left, where they use powder sieving and a top up with virgin powder.